All right, so it says suppose g is continuous function, which means we can do an integral for it. Now, what I notice here is we want to get from the interval of 3 to -2. So I'm going to share with you one of the properties we had is that if I want to get the integral from a to b, so if I had some graph, and let's say this was a, and this was b, and I'm getting the integral there, that's going to give me the area from here to here. So if I did the integral of a to b, that will give me this whole area right here. Well, if I have another point somewhere in between these two, let's say c is right here, that if I get the area from a to c, and then I get the area from c to b, if I add those two up, they will equal the area from a to b from back in geometry days. So what that means is if I can break this a to b up into going from a to c will give me this red area, plus then I add on to that the integral from c to b, that will give me this green area. And if I add those two together, that will equal this a to b area. So the key to this is you've got to get this top interval and this and the next bottom interval the exact same letters to do this. So the question is, what do I know up here? What do I know up there about being able to get from 3 to -2? Well, if you look, this is 3 and this is -2, and these are 1s. So there's actually two ways to do this problem. Okay, one way is I could say that this is equal to the negative integral from -2 to 3 of gx dx. To save time, I'm not going to write the gx dx down all the time. So over here, I could say that if you look at this one and this one, they're the same, right? So I can say that that will be the integral from -2 to 1, the negative integral from -2 to 1, plus the integral from 1 to 3, or the, from 1 to 3 of the gx dx here. But I still have this negative that is out front because I flip-flop these. So, and again, I should put gx dx and all this stuff. So what that means is I can plug into this thing, the 2, and I can plug into this, the -6, which gives me a -4, which tells me this area would be 4. That's the answer to this problem. The other thing you could have done is you could have left these the same. You could have left these the same and then flipped these two upside down and said, actually, you would have started with this one. If you flip that one upside down, you could say that's 3 to 1. But then that's going to be a negative of this original number. So in other words, and then this one you'd flip upside down too to get from 1 to -2. Again, these two have to match up. And since I flipped this upside down, that would make this a +6 because it's got to change that sign. And then this one flipped upside down, it's got to change that to a -2 because I flipped it upside down, which would also give you the same value of 4. So you okay with that?
Yes. Yeah.
Okay. Do you have any more?
Nope, that's all for me.